Morning, everybody. Happy Monday. Yeah, I know I'm not here again. I've got a long meeting today, so I know it's block day. I tried to look for a Dr. What's that guy's name? Dr. Straight Edge video. I couldn't find anything, so I'm just making this one this morning. This is for adding and subtracting radicals. I know this is new, so we're gonna try to get through this together and see how we can work it out. If you guys want to do a weekend update with Ms. Melman, that would be cool. But I don't know if she wants to talk to any of you. Sorry, Melvin. Okay, let's take a look first at our rules. So for adding and subtracting radicals, you're gonna need to break the radical down into like radicals, okay? So that means they have to be the same, and you cannot add or subtract different numbers under the radicals, the ones inside the house or inside jail or whatever you wanna call it. So if we look at our examples, 3 radical 3 plus 9 radical 3, you can add the outsides together and the inside stays the same, right? Because they're common interior radicals. So you just add up the outsides together, it's 12 radical 3. If we look at the next one, 27 plus 48 minus 12, okay? What you need to do is break down these radicals, and they'll work out this way, so that I didn't complete doing it because it just ran out of room. So you break radical 27 down, and you get 3 radical 3. You break radical 48 down, and you get 4 radical 3, and 12 is 2 radical 3. So do you see we've got all radical 3's under there? Now we can do 3 plus 4 is 7, minus 2, which is 5 radical 3, okay? If you did have something where it was 3 radical 3 plus 4 radical 3 minus 2 radical 9, or not 9, 10, then you would just leave this as it is. You wouldn't compute these. So if you get a problem like that, which I don't think we have any of those right now, you would leave it as like you couldn't add that. It's not a like term. You can combine these two. All right, take us on the right with real quick in your calculator. If you need to pause this or, I don't know, do something. I'm gonna see how this works. Like just barely balancing this. Okay, so 45, radical 45 plus radical 5. So first let's break this down into 9 and 5. 9's gonna break down into 3 and 3. Look at that, perfect square. Let's bust that to the outside. That 5 can't break down any further. So now this turns into 3 radical 5. Let's just carry this part down, plus 5. Sorry, radical 5. So now what we need to do is we're going to need to add those together. And just like always, there's an invisible 1 out here. Even though we didn't write that 1, there has to be 1 on the outside. So it's actually 3 plus 1. So our answer to this one is 4 radical 5. Because although there isn't anything out here, there's an invisible 1. Let's do another one together. Radical 5 plus radical 20. Let's break this down. You know this. 5 and 4. 2 and 2. I'm actually having to go look at the phone screen when I do this problem. It's kind of confusing. I'm like I don't know, movie star or something. Radical 5 plus 2 radical 5. Now again, we're just adding the outsides together. So we're gonna get 3 radical 5. You should be pretty straightforward going on. There's a lot of the same. The next section you get to, so you can pause right here if you want to do that. You should be able to work up to 15 pretty efficiently here. That's the same. Then you get into coefficients. Now it's going to be the exact same thing. Right here, look at this. You can actually just add or subtract these together right now. But once you start getting into coefficients, you're still breaking them down the exact same way, and you're getting down to that like radical. Okay, and then you're going. You guys have plenty of time today. Ask Miss Melman, but you should be able to get through a bunch of these today, okay? So let's work. Let's go get them. And I don't know, keep it real. See you later.